research methods that we use for the different research designs that we heard that today. Okie dokie. Do you have any questions? Yes. It will be up after Friday. Oh yeah, I lecture first and then I give you the PowerPoint. Okay? Alright, any other questions? Okie dokie, well then let's get started so you guys can get out of here. Alright, so what we're going to do is we're going to describe the scientific method. I hope this is already clear to you guys. And we're going to differentiate the theories, hypotheses, and research. I know you guys are really excited. Okay, so what we as psychologists and what we like to study, okay, is the what, when, and why of behavioral processes. Okay, why do we behave the way we do? When do we do it? Well, what do we do? Okay, and we use the scientific method because it gives us a systematic way of collecting data and doing our research. All right. It's more objective than casual observation. And what do I mean by being objective? I mean that we're trying not to have any bias here. Okay? We're trying to eliminate our bias. But I'm going to warn you that we are going to talk about how we are biased as researchers. Okay, so remember that. But we try to be as objective as we can be. We follow carefully planned steps to try and eliminate some of that bias and get as much awesome data as we can get. Okay, and again, we are freaking biased. Alright, so it depends on theories, hypotheses, and then our research, right? We gotta have all these things in order to participate in the scientific method. So our theory, let me start out. Our theory is an explanation of how a phenomenon, an observable thing, occurs. Okay? The interconnected ideas and concepts used to explain these. Okay? So we have our theory. Alright? And these then generate hypotheses. Okay? Our research questions, basically. It's a testable prediction about the outcome that would support the theory. Okay? So my theory is that depending on where you sit will depict what grades you will receive in this class. Okay? So my theory is that if you sit further in the back of the class, you'll get a worse grade. If you sit closer to the front of the class, you'll get a better grade. Okay? So then my hypothesis would be the closer you sit to the front of the class, the better grade you're going to get. Okay? I could also say my hypothesis is the closer you sit to the back of the class, the worse grade you're going to get. Or I can even flip them. Okay? So I have all these testable research questions. Okay? All these hypotheses that have been generated in my theory of where you sit changes your grade. Okay? I can even say that if you sit at the back of the class, the better grade you're going to get, and vice versa. So I've already got 4 research hypotheses I can go off of. Yes?
What if you aren't able to test it? Or test it means like recreate the situation that you're thinking of, right?
If you can't test it, then it's not a good theory. Theories have to be able to generate hypotheses which can be tested. Okay? We have to have that. And we'll talk about how you can, because you get research questions that seem really daunting, and you're like, how in the heck am I going to do this? We'll talk about ways that you can make it into a measurable research question. Okay, so we've got our hypotheses, and now we do our research. Okay, we gather our data, and we analyze it, and things like that. That's our research, okay? So do I have any questions so far about theories, hypotheses, and research? Good? Okay. Alright, so there's our little diagram of how we do the scientific method. We first start out with a theory. We create our hypotheses, our predictions. We then do our research, and we find either the data supports our theory, which is fantastic, okay? So then we can probably refine our hypothesis, try and find some more supporting data. Or we find our data does not support our hypothesis, and what we thought was right was wrong. And so we go back up to the theory, we create more hypotheses, we test them by research. Okay? Make sense? Alright. So here's another one of theories of the scientific method in action. We're talking about alcohol here. It's really hard to read, I know. But they're saying that e-cigarettes and drinking alcohol impairs driving ability, and you know, observe people drinking alcohol. Hypothesize that people who consume alcohol tend to display poor coordination, poor motor control, and people who do not consume alcohol. So you can observe them with their coordination skills. You test your hypothesis by selecting the most appropriate research method. So you might begin by having some participants in your study drink alcohol and others drink water. We're going to use these examples forever. And answer data, and then you submit your results and try and get them published, which is the most thing we talked about. Okay? We also try to overtake our research. Okay? And the reason why we replicate our research, so we try to do it over and over and over again, and the reason why we do that is to make sure it's valid. Okay, to make sure that, we didn't just get the random results. We want to make sure that we keep getting the same results or very similar results so that way we know our research is effective. Okay? Alright. So theory should generate hypotheses. We've already kind of talked about this. A good theory with a variety of testable hypotheses. Okay? Just with my theory that where you sit in the class, we came up with 4 testable hypotheses right off the bat. Okay? So we can say that's a pretty good theory. Okay? Now we have to test it to say if it's a really good theory, but it did provide hypotheses for us. We also see this with Jean Piaget's theory of infant and child development, which generated thousands of hypotheses in scientific papers. In fact, a lot more theories were stemmed off of his theory. We saw the stages of family development that came off of this. We saw the stages of adult development. We saw stages of moral development. And all these kind of started with Jean Piaget's idea here. Freud's theory also of dreams and the symbolism in dreams stemmed tons of hypotheses and other theories and things like that. We had a lot of information come from that. We saw a lot of scientific data that was being performed and getting and obtained stemming off of this. Okay? A lot of other scientists and researchers went and started testing his theories and came up with their own hypotheses about symbolism in dreams. Okay? And about the unconscious with the consciousness and things like that. Okie dokie? So that was a really good theory for us. Alright, so let's talk about unexpected findings. That's when it happens. Alright? You might find that there's a fluke in your research, but because of your fluke, you got some really good information. Or there might have been a little bit of a mistake or an overlook, or your information just didn't come out the way you thought it was. And those can be really good things. We talk about serendipity. Okay, and serendipity, the definition is unexpectedly finding things that are valuable or agreeable. Okay, we like it. Okay, even if it doesn't go exactly as planned, if it comes out with some good info, we like it. So here's an example of that. These researchers were researching, brain cells? Let me look. Brain cells in cats. Okay, and what they were doing is they were looking to see how the brain cells were stimulated, and they thought they were stimulated by dogs. Okay, so they were showing the cats these dogs, and they realized that they weren't being stimulated the way that they thought they were, or that they thought they would be. Okay, and so they were getting a little frustrated and stuff like that. But then they had a malfunction on the projection, which created lines instead of dogs, and it really stimulated the cats. So then they found out from this mistake that cells respond to lines and edges, not dots. So that's pretty cool, right? I think it's cool. Okay. So let's move on to 2.2, and we want to distinguish between the different studies. There's 3: descriptive, correlational studies, and experiments. We will talk about the advantages and disadvantages, and we will also talk about sampling. How do you get people in your research? Okay? All right. So let's talk about a variable first. Okay? The variables are things that vary naturally in nature. Okay? They are also the things that we want to study. We will get more into variables. I hope you guys have all heard about variables before. But in psychology, we have 2 things that we have to do to a variable to make it to be a part of our study. Okay? First, we have to operationalize it. Okay? And that just simply means that we define it. But we define it how we, not how we need to, but we define it in a way that everybody can understand, and it is a, I can't even say universal definition. Let me give an example. How would someone define coordination? Is there an absolute definition of coordination? Yeah, right? So if I talk about coordination, how many people would think of different things for coordination? Everybody, right? So how in the heck would I study that and measure it? It's crazy, right? You can't. So we have to operationalize it. So what are some ways that we define coordination? I'm sorry? Well, when I'm talking, coordination that way, but when I'm talking about, I guess I need to be more specific. See, just right there, we have two different definitions of coordination there. I'm talking about more coordination. Okay?
Sobriety test what they do.
Thank you. What are some of the things that they do in sobriety test?
If you walk straight line.
If you can walk a straight line, we can define coordination that way. What else? Play an instrument. We can see that. Yeah. ABC's backwards. ABC's backwards.
Stand on one leg.
I'm sorry?
Stand on one leg.
Standing on one leg. Touching your finger to your nose, right? All those things we can use to define coordination. Okay? So now we know that there's different definitions of coordination, but what one are we going to use? So let's say I am studying the effects of alcohol on coordination. I'm just defining it, okay? I'm going to use the nose thing. So now I have to quantify it. What do I mean by quantifying it? I mean that we have to make it in a way that we can measure it. Okay? So what we can do is we can say, obviously this is right on point, right? If I'm touching my nose, it's pretty good. But if I miss it by 3 inches, my coordination might be a tad bit off. But I can measure that, right? The distance between my nose and where my finger touches. I can also measure the times that I miss my nose. Okay? I can measure, if we do balance, I can measure if you are, how long you stand on one leg. Okay? How many times you fall over in a 5-minute period. I can measure if you're walking a straight line, how many times you step off of the line. How long it takes you to walk that straight line. Those are all ways I can define coordination. Okay? And those are all ways I can measure it. So we have to define it so everybody knows what we're talking about. And then we have to be able to measure it. Make sense? Okay. You guys are staring at me. Alright, so descriptive studies. We just like to observe people. We also call them observational studies. I know, we're so creative. And we know the behavior of people or other animals through by a systematic and objective analysis of behavior. Okay? So we're not biased. We're just watching people. We're not doing anything to change their behavior or anything else like that. We just watch. Okay? There are 2 different forms of descriptive studies, and that's naturalistic observation, which is passive. Okay, so you don't get involved. So let's say you want to study how kids interact in the high school cafeteria. So you kind of just sit there and watch. They may know you're there. They may not know you're there. But you don't talk to them. You don't get involved. You just watch. Okay? You might listen to them, to the conversations they're having or something like that. But you do no intervention whatsoever. You do not get involved. Then you have participant observation, which is active involvement. Okay? So maybe you decide that you do need to get a little bit involved with them to observe them better in this cafeteria. So you might sit with them at one of the tables and listen to what they talk to. Okay? Maybe you're going to see if they accept you into their group, their table group. Okay? Different things like that. So they know you're there, you're interacting with them, okay? But you're still not manipulating anything in the environment. Alright, does that make sense? Okay. So then we move on and we have developmental designs in our descriptive studies. And these are longitudinal and cross-sectional. Longitudinal. What do you think when you hear longitudinal? Long. I think of long lines, right? Okay, so we can kind of think of longitudinal as being on a long timeline. Okay, longitudinal studies are the ones, and I know you guys know what I'm talking about, the ones where they might start with a certain group, maybe at birth, and they watch them all the way through growing up. Have you ever seen that, like, the study stuff before? Like, they might meet with them every 5 years or something like that. We see a lot of documentaries on these kind of studies. Okay? Problems with these studies are you can lose participants over a certain amount of time, right? Okay, if you're going to go meet with people every 5 years to see how they're doing, then they might have moved and you might not have known about it. They may decide to do it like it anymore, things like that. You may lose people. They're expensive. Okay, because you got to track people down. Alright? You're with them for years. Okay? I mean years. This is a longitudinal study. It takes years to do. Sometimes it goes on for generations. Okay? So they are expensive. And like I said, they take a long, long time to do. And then we have cross-sectional studies. Okay? Cross-sectional, they are quicker. They are not as expensive. And you get your information a lot quicker, okay? What you do is you get a big group of people who might, let me give you an example. When they do these studies, usually what they're doing is they're trying to study the impact of age or development of age, okay? So with cross-sectional studies, what they would do is they would get large groups of people, and either they would be, young or old or something like that, so that way they can see the different stages of development of age. Okay, does that make sense? They probably meet with a big group once with all these different ages. They get all the information they need, and they're good to go. Whereas in the longitudinal, they stick with the exact same group for years and years and years and observe. So here's examples of naturalistic observation. I know it's kind of dark, but she's taking pictures of gorillas and just observing them. And then here's participant observation. He's actually with the tribe and doing what they do and a part of it. Okay, and here's a longitudinal study. They actually, this is in a documentary called Up, I think. But they went and they slept with these women all the way through. These are the exact same women in all these pictures. Okay, and then here's a cross-sectional study. We can see that there are a variety of people in these groups. Okay, disadvantages, we may not be able to identify all the variables involved in these groups. And we're going to talk about that because I know that's in this clear time. All right, so have any questions so far? Let me know if I'm going too fast. Yeah, what? Where's something? Nope. Okay. All right, so let's talk about observer bias. When you guys do research and you say, hey, I really hope this happens in my research, like I hope I found this. You guys do that? I think we all kind of do. But that's observer bias. And we'll talk about it. It's systematic errors in which are your observations that occur because of an observer's expectations. Okay? When we do research with hypotheses and things like that, like we're trying to prove something, we often have expectations. Okay? We want our hypothesis to be true. So we have these expectations in our research, and that can have bad effects or skew our results. Okay? For example, they did this study in a university. What they did is they had a class of students, and they divided them up into two groups. Okay, and what they were doing is they were training rats to run through a maze. And so the students thought that they were just training these rats. The professor was actually observing the students. So it was a really cool experiment. What they did was he told one, we'll say group A, he told them that their rats were bred to be amazing maze runners. Okay, like that's exactly what they were bred for, was to run mazes. And the second group, Group B, he told them that their rats were not bred to be good performers. Okay, so they weren't good at running mazes at all. So they did this study, and the students were training the rats and things like that. And what they found, and yes, the rats had no genetic differences. Okay, they were the exact same. All right. But as they were doing the study, they found, or the professor found out that students in Group A would be amazing maze performing rats. actually perform the task faster than group B. How come? Does anybody know why that happened?
The server bias.
Okay, but give me an example of why that might happen with observer bias in this situation.
They already had the expectations that the rats knew what they were going to have to do, so it's just that thing up.
They probably treated the rats differently, right? We treated the rats differently than we did the group B. Okay? So yeah, your answers are right. Hit that great on the head right there. But yes, they treated them differently, okay? Because if you have, think about it. If you have a rat that you think is, stupid in the science and can't make it through a maze, how are you going to treat it? Like it's stupid, right? Are you going to treat it like that amazing maze running mouse or rat, whatever they are? No, you're probably going to treat it differently, right? Because you have different expectations now, okay? You expect that rat to do amazingly running through that maze, so you might train it differently, okay? Making sure that it succeeds in this maze run, okay? Compared to the rat that probably can't do it. Stupid rat. He's running into the wall again. Stupid rat. And then I'm done. If my rat can do it, I can be done, right? Why do it if the rat's stupid and can't get it? Our expectations changes our behaviors, which can change our results. And there's an example of that. Okay. So let's get into, one thing I do want to mention is that we do need to be aware of our expectations, okay, when we do research. Alright, we need to be aware of them, understand that, we do want certain things to come out in our research, right? We want to find certain things, that's why we do it. And so we need to be aware of that, we need to be aware of our expectations of how it might affect our research, okay? Because we don't do these things on purpose. Okay, most of these things are unconscious. So we try to be aware of it before we start our research, so we understand that. Alright, so let's talk about correlational studies. Alright, so one way I like to remember correlational studies is if you look in the word, it says relation, right? So let's talk about relationships. Okay, correlational studies, we examine how variables are naturally related in the real world. We say that these two variables have a relationship with each other. Okay? We do not attempt to alter variables in this type of study. And we cannot draw causal conclusions. Let me emphasize causal conclusions, not casual, causal. Okay? Causal, I'm talking about one variable absolutely causes the other. Okay? Those are very hard to prove. And we'll talk about that here in just a little bit. But we cannot, in correlational studies, we're just saying that they have a relationship, okay? That usually when variable A changes, variable B is going to change. Or variable B changes, that variable A is going to change. Okay, that's what we're saying there, is that there's some relationship between the two variables. In causal relationships, we're saying that absolutely, without a doubt, 100%, variable A causes variable B. And we'll talk about why that is so hard to actually do. Okay? Alright, so just remember the relationship. So here we're talking about if you have obese parents, what are the risks of their offspring being obese? We know that there's a correlation there. Okay, we studied it, we understand that. But what variables go into obesity?
Eating habits of the parents wouldn't be eating habits of the children.
Okay, so we have eating habits of obesity. Okay, that's a variable of obesity. What else?
Activity level.
Activity levels is a variable. What else?
Heredity.
Heredity, our genetics, our biology, our metabolism levels, all these things like that. Can we isolate one absolute variable and say that that causes obesity? No, we can't, right? No. So, we can say that there's a relationship there, but we can't say that the biology of the parents will absolutely cause obesity of the child. We can't say that the eating habits of the parents will absolutely cause obesity of the child. Okay? We can't say that the activity level of the parents absolutely causes the obesity of the child. we know this is a relationship. Okay? And that's what we're getting at. Alright, and so now we understand that there's different variables, right, that play into this. So let's get into what we call directionality problems. Directionality problems are when we find that a relationship between two variables, okay, so we know that they're related, that they impact one another, but we cannot say which one caused changes in the other. Kind of like which came first, the egg or the chicken, okay? Alright, so we know that there's a relationship, but we don't know if it was variable A that caused it or variable B that caused it or what. Okay, we just know that they change together and that they are related. For example, does sleep cause more stress, or does more stress cause less sleep? Who's heard it both ways? A lot of us, right? In fact, I've even heard, and I've even taught my own clients in stress reduction, that the less sleep you get, the more stressed you are. The more stressed you are, the less sleep you get. What's that, right? But we don't know which one causes the other. We just know that they are related. Alright, everybody got a directionality problem. Pretty simple, not doctor. Okay, so third variable problem. Just like we were talking with the obesity case, we saw that there's more than just two variables, right? Not everything's black and white, okay? And that sucks for us, because we'd like to have just two variables, because it makes things a lot easier. But we understand that in life, there's a lot of variables playing into things. Okay, so we have a third variable problem, which is that we cannot be confident that an unmeasured variable is not the actual cause of differences in the variables of interest. Oh, that's very wordy, right? Well, they did give you an example about drinking and driving. Okay, and stress. Yes? Do you have a time machine? It's going around. Okay. Anyways, so, they give you an example about drinking and driving, okay, along with stress. They say that we have variable A, which is drinking before driving, variable B, which is distracted while driving, and then stress is our variable C, 3 variables there. So what they say here is stress causes some people to drink before driving. Yeah, so stress causes you to drink. So, but then we see that stress also causes some people to be distracted while driving. Yep. So you might be stressed out and drinking and driving, and now you're distracted. Okay, so you can see how stress is sort of bigger than the limits. Here's another example which I think might be a little bit easier to understand. Children who go to preschool are better readers in first grade than those who did not. Let's identify our variables. I have 2 defined variables in this hypothesis. Anybody tell me what they are? I'm sorry, what was it?
Do you go to preschool versus going down?
Yes. Okay, going to preschool is a variable. What's the other one? Reading, I heard it. Yes. Your reading level. The reading levels of these kids are the other variable. Okay? So, what are some other variables? Because that makes sense, right? You know, if you go to preschool, you might read a little bit better because you teach you how to do that than kids who don't go to preschool. But what are some other variables that we might have to consider with that situation?
Consider the parents.
The parents! Yes! Thank you. That is our third variable. Are the parents invested more with the kids who go to preschool than the parents that aren't being there to preschool? Are they doing more homework with them? Are they reading with them more? You know, are they not? That's another variable that we have to look at. Okay? In fact, I had a student last class that said, well, what if the parents who are taking their kids to preschool are working all the time? And then the parents who aren't taking their kids to preschool are the ones that are sitting there reading with them and, you know, doing stuff with them. Something we have to consider. There's our third variable. Okay? So we want to measure our 2 variables, which is if you go to preschool, you're going to read better. But we have to consider the parental investment in that as well. Okay. Any questions about the third variable problem? Alright, I am like deterring all of you guys from doing any research, right? I'm just going to get that up. Alright, so let's talk about ethical reasons. We're going to get into ethics probably on Friday, a little bit more in the research. But one of the biggest ethics we have to consider when we are doing research is we do no harm. Okay? We can get lots of trouble in jail time if we induce harm. Let's see here. If you're doing a research project and your subjects happen to be humans, then you have to go through what we call the IRB. Okay, specific board that almost every entity that does research, universities, colleges, agencies, organizations, whatever, they usually have an IRB board. Shawnee State has an IRB board. And you have to go through them to get approved to do your research, so that way they can make sure you are following all of the ethical standards and you're not inducing any harm. So let's talk about that. One of the examples is do soldiers who experience severe trauma during combat have more difficulty learning new tasks after they return home compared to soldiers who have experienced less severe trauma. Okay, well, we could set up an experiment that, provided these combat situations, and we had two groups, and the first group we, had them experience more trauma and simulated combat situations compared to the next group. What's the problem with that? We're inducing the trauma, right? Which could induce harm. So we can't do that, it's unethical. So what we have to do then is we use these correlational designs so that way we can, use up the time there and study the relationship between variables as they return home. Okay, we can't induce the trauma, we have to wait until these soldiers return home, and then we can measure these variables. First, we have to operationalize or define trauma, right? The levels of trauma, so that way we know what we're talking about. Okay, and we can rate them. And then what we have to do is we have to, maybe we tell them that we want them to learn a new computer program. So then we have to sit there and watch that and learn this new computer program. And if we say that they experienced trauma at a level 9 when they were in combat, and they do poorly, we're going to measure that. Okay, and that's the way that we can do that research. Okay, but we can't cause anything. We also use it in psychopathology research. When we're studying mental health disorders and things like that, and mental illnesses. We can't induce a mental illness. I mean, we sure can, but it's unethical to do so, so we don't, obviously. We will get people who have been diagnosed and use them. Okay? All right. Any questions about that? We'll get more to that like that. Making predictions. So correlations, they help us understand the relationship between variables, right? And if we understand those relationships, we are able to make predictions, which is what we want to do, right? Remember I opened the class saying that we want to understand why we behave the way we behave and all that fun stuff? Well, this is how we do it, okay? Correlational research has identified a strong relationship between depression and suicide. When I was working in direct social work, part of my job was to assess for suicidality. Okay? I would actually go into the hospitals and the jails, and I would assess if people were suicidal or not. Okay? I have to get it at my agency, hospitalize people, the whole 9 yards. But how was I able to measure the risk? I was able to do that because we've done these correlational studies that show me the relationships between depressive symptoms and the risk for suicidality. Okay? If someone just told me not having a good day, I just feel sad, I'm not going to punch somebody, then I'm fine. Doesn't really raise a red flag for me. Okay? But if someone told me while I was interviewing them that, I have my pills, they're in my cabinet, nobody's going to be home at 4 o'clock, I think I might take them. That to me says, okay, he's probably at a level 9 of suicidality, I need to get hospitalized or something like that, I need to do something right now. Okay? How do I know the difference is there? Because we've done the studies and seen the relationships between the two. Okay? Alright. So, now let's talk about experimental research design. These are our fun ones that everybody wants to do. Okay? We manipulate one variable to see the effect on the second. Okay? So remember I was talking about my hypothesis about where you sit in the room? Okay, good. I just did this lecture, so I forget. But, okay, so we'll use that as an example. Okay, so my hypothesis is that if you sit in front of the class, you're going to have better grades. Okay, so let's identify our variables here. We have the independent variable, which is the variable that's manipulated. It's the one that would change. Okay, and then we have the dependent variable, which is the one that is measured. It's the one that is affected by the independent variable, the one that we want to know if it has changed because of it. Okay, so out of my hypothesis of closer you sit to the front of the class, the better grades you're going to have, what is the independent variable?
Where you sit.
Where you sit, yes. Okay? So if you sit in front of the class, that's my independent variable. And then so what's my dependent? Your grades. Okay, yes. Okay, so what I can actually do in this study is each week I can administer a quiz. Okay, and I'm going to say that first 2 rows, that's considered front of the box. And I'm going to teach you, okay, and then we give everybody a quiz, and then the next week everybody shifts. And we're going to see if there is a big impact in that, okay? All right, so now let's talk about experimental groups. Okay, when we use experimental research designs, we like to have 2 different groups, okay? And we have a control group or does anybody know the other word for it? You guys are gonna like, oh, that's what it is. I thought I heard it. No. And we have 2 different groups, and we're looking at the differences. What are we doing? What? It's a control group, but what's another name for it? See? Comparison group, okay? You guys have heard of comparison groups before. It's the same thing as a control group, okay? Alright, so we have the experimental group, and that's the group that we give the intervention to. Okay, so let me give you a new example of an experiment. I have 2 psych classes. Okay, you guys are pretty much the same. I have a majority of majors in both of them. I have, looks like about the same ages. About the same number, about the same amount of boys and girls. It looks good, okay? So what I'm going to do is one group, I'll say for you guys are going to be my experimental group. I'm going to give you guys relaxation techniques every time before we start class. Because my theory is that if you do the relaxation techniques every time before class, your grades will be better. Okay? So as my experimental group, I'm going to give you guys the intervention. My control group, which would be my other class, which is almost the exact same as you guys, I don't do that at all. Okay, and that way I can compare you guys. Okay, see if my intervention is actually, it works. Alright, now, I kind of talked about causality a little bit. Okay? This is what we do when we examine causality. Okay? This is where the independent variable is assumed to be the cause of any change in the independent variable. And the reason why it's so hard to really prove this is we have to absolutely isolate the one variable and say it is the only variable that's making any change. Okay? And we can see, we've already talked about how many other variables there are in our research, right? Even if we're only finding 2, I can still identify, even in my, we're sitting in the front of the classroom and get better grades. I can identify so many more variables there, okay? Such as maybe people who sit in front of the class study more. Okay? Maybe, I'm talking really loud, but maybe people in the back can't hear me talk. Or maybe because they can't see my eyes as well, they fall asleep more. There's other variables that play into this, okay? It's not just where you sit. So, if I were going to try to play time to causality here and say that exactly where you sit does affect your grades, I have to isolate that. I have to prove that sitting in the back of the class doesn't make you fall asleep. I have to prove that the people in the front are studying just as much as the people in the back. Okay, I have to prove all those things. I have to isolate the one. Okay? So that includes and assumes rigorous control. Okay? I have to show that it was just that one variable, that other variables don't have an impact. And what I've also just talked about is a confound. It's anything other than the independent variable that affects the dependent variable. So the amount of studying that the people in front do compared to other people is a confound. Okay? The amount that you sleep in class, confound. Okay? The amount that you can have eye contact with me because that keeps you more attentive is a confound. Okay? There's all kinds of different ones in that. Let's see here. So if I do the relaxation technique experiment, another confound could be I might accidentally, not thinking about it, change the way that I lecture to you guys. Because I want you to have better grades because I'm giving you the relaxation technique because that's what I expect. And I might change the way I lecture to you compared to my other group, right? That would be a confound. Okay, so we have to be aware of these things. And that's why it's so hard to prove causality. Alright, here's a fun little diagram. I'm actually going to skip it. Okay. Let's get into sampling, and after sampling we'll be finished. There's a couple slides, so I'm too excited. Okay. So how do we get our people in our groups, in our experiments? Okay. Now let me define some terms for you. First of all, we want to generalize our findings, which means that I would like to take my findings from this small group and apply it to a huge group. Okay? So if I'm doing relaxation techniques with you guys, and I am looking at all college students, so I would like to apply it to all the college students. Okay? And that was generalizing it. So what we do, let me sample for a minute. Let's go to population. In my study of relaxation techniques, okay, if I'm doing a study and I say that relaxation technique for a class will improve the grades of college students, can anybody tell me what my population is in my study? College students, okay? And I'm talking about college students in the country, okay? Now, if I were to have a sample and I had to study my population, my whole population, I had to study every single college student with relaxation techniques. Is that possible? No, okay, because not only do we have students in all these universities, but now we have online students. Okay? Now I have to go and like do their houses and stuff. There's no way, it's impossible to do. So what we do is we take a sample. Okay? We take a sample of our population that we're studying. And so what I try to do is I try to get a sample that looks as much like my population, that represents it the best. Okay? This classroom would probably be a good sample for college students in this area, right? Because now I gotta think about culture and all this other crap too. But we don't feel generalize it. That's why variables are so important. But you guys will be my sample. Okay? Now there's different ways to sample. We have random sampling, which is every person in the population has an equal chance of being selected. If I use all of the college students in America, and I gave them all the same equal opportunity to be randomly selected in my group, where would they come from? Everywhere, right? I have people from California, from Alaska, from Florida, from Hawaii, from, the Midwest, everywhere. It would still be impossible, okay? So then what I do is I do a convenient sample, okay? A convenient sample is just simply those people who are available to you at your experiment, or during your experiment. So you guys would represent a good group for college students. I've got you at my fingertips. You guys would be a convenient sample for me, okay? If I use, a better example would be me randomly selecting from all of Shawnee State University, okay? Because then I would get a really good random selection, but it's still convenient because it's from Shawnee State, okay? Alright, then we have external validity, and this is the degree to which the study can be generalized outside laboratory. So let's say I do my experiment here a couple of times. I realize that, I'm getting the similar findings. I do it at another university, I do it at another university, and the findings become similar. Okay, and that's external validity. We want external validity. Selection bias, here we go, bias again. Groups are not equivalent because participants in different groups differ in an unexpected way that affect the dependent variable. So let's talk about the alcohol experiment, okay? With it decreasing the coordination. What if I do random sampling, okay, and I find that I have my two groups. This group has a lot of little women in it. This group has a lot of little men in it. How is that going to affect my results with alcohol? If they get alcohol, it's little girls. We have differences in consumption.
Yeah, one has a higher alcohol tolerance than the other.
We have differences in tolerance. Yes. Okay, so that can skew it, right? And that's selection bias. Okay? When we see these unknown variables, with these different variables such as tolerance, okay, one group might be more coordinated than the other. Okay, we might see things like that. So what do we do? Okay, how do we even that out? And what we do is we do random assignment. Okay, random assignment helps us even out the groups. Okay, and what we do is as simple as, I've done this before, you might take all the participants' names, put them in a hat, and draw out for your control group. Okay, that would be random, right? But put all your guys' names in a hat. And I started drawing them out, and I said, this side drinks alcohol, this side drinks tonic water. I'm probably gonna get a pretty good mix of boys and girls and different ages and things like that, right? Yeah, probably. You guys are kind of gonna, the groups are gonna kind of average out with each other. Okay? And that's how we try and eliminate some of these variables that could affect our dependent variables. Okay? Such as, when you do random selection, this group probably isn't going to have higher tolerance compared to those groups, right? We try and even it out. Okay, now here is our fun little diagram that shows you about random selection and all that kind of stuff. You guys can look at it when I get out the blackboard tonight if you want, but I hope I've explained it well enough that you don't need a diagram. Do I have any questions or anything like that? Okay, right. See you Friday. We'll finish.